Hello everyone, my name is Priyanka and I welcome you all to my session. So today's question is from the topic optics and I have already written it on the board. So the question says, if the image formed by a lens for all positions of an object placed in front of it is always erect and diminished, what is the nature of the lens? Alright, so there are two types of lenses. So we can say that lens are of two types. One is convex and the other is concave. The convex lens, so we are talking about convex lens, it forms both the erect and inverted image depending upon the positions of the object in front of the lens. However, the concave lens always forms an erect and diminished image for all the positions of an object in front of it. Therefore, our answer is concave lens. So let us make a ray diagram for the image formed by a concave lens. Alright, so to make the ray diagram, the most important thing first is the principal axis. Alright, so here is our principal axis. Now let us make a concave lens. So this is our concave lens. That's going to be the pole, that is point O. We can make the focus F and the radius of curvature that we defined by 2F. It is here. Alright, so let's make the object now. So our object is standing in between F and 2F and we're going to name this object as AB. So as per the rule, let us say that if a ray is passing parallel to principal axis, because it is a concave lens, it is going to diverge. So it's going to move something like this, and when we are going to trace it backwards, it is going to meet at the focus. That is, it will seem as if it is coming from the focus. Another ray, if we talk about, let's just take another ray to be passing from the pole. So it is going to be something like this. And we say that if a line is passing from the pole, it is going to get undeviated. So that's going to be another line. So here we have two lines. One is this and the other is this one. We can see that these two lines are meeting at this point. So this is going to be our image and it is going to be point A dash and B dash. So AB was our object and A dash B dash was the image. So see, we can see here that our image is actually erect and also it is diminished. So, and also the point to note here is that it is virtual. The image formed is virtual. That is, the rays are actually not meeting, but we are making them to meet at one particular point. So this explains the ray diagram or the formation of image with the help of ray diagram by a concave lens. Now let's move to the next part of the question, which says that if the numerical value of the power of the lens is 10 diopter, what is its focal length in Cartesian system? Alright, so when we talk about Cartesian system, we have to make sure that we are considering sign conventions properly. Given here is the numerical value of the power of the lens, which is 10 diopter. That is, we are given the power of lens which is 10D, that is 10 diopter. Now that it is a concave lens, therefore we have to consider it to be as minus 10. So the formula for the power of lens with respect to the focal length is power, which we give by P, is equal to 1 upon F, where F is in meters. Alright, so the power is given to us as minus 10, which is 1 upon f. So f is going to be minus 1 by 10, which is minus 0.1 meter. So this explains our answer, and it also, the sign explains us that it is a concave lens, because if in case it's going to be convex lens, the focal length would be positive. So I hope I was able to give you a proper understanding for this question. Feel free to provide any relevant comments. Thank you so much for your time. Have a great day. Bye bye.